Hey, what's going on, guys? We have this question right here. It's asking find the value of c that makes the function continuous on R, and we have this equation right here. On this is the one we have to derive. So first of all, in this case, they have given less than when x is equal to less than 0. This is the value, and uh, greater than no equal to 0. This is the value. Also, we know that since uh, since f of x is polynomial, we know that this x greater than x is equal to x less than 0 is continuous, and x greater than 0 also continuous, right? But but to x is equal 0 to be continuous, what has to happen is from limit when limit x approaches 0 from the left side, f of x should be equal to limit x approaches 0 from the right side, f of x should be equal to limit f of not limit f of 0. So this is the condition it has to have in order to be continuous at x is equal to 0, to be continuous at x is equal to 0. So this is the condition it has to follow. So since we have formed the relationship, let's see how we can find the values for this. First of all, I am finding a limit x approaches 0 from the left hand side. Let's see what happens if I find that. Limit x approaches 0 from the left hand side, f of x should be equal to left hand side mean is the lesser than 0, x is lesser than 0. Therefore, I have to take this equation right here. So c power 4. So left hand side, I have to mention limit x approaches 0, c4 x square sine 1 over 5x plus c square. Now I simply substitute this 0 for the x values. If I substitute, this whole thing becomes 0 because 0 multiplied by anything is 0. Therefore, I only left with c square. Then let's take the right hand side. Limit x approaches 0 from the right hand side. When limit approaches 0 from the right hand side, it means it's greater than 0. So we have to take this equation right here. It's going to be limit x approaches 0. You can also put left hand side, right hand side here if you want. Then we can put c plus 2 1 plus x, which is equal to, now I substitute the 0 for x. If I substitute, it's gonna become c plus 2. And if you substitute for f of 0, it's the same equation. It's gonna be same thing because c plus 2 1 plus 0 is gonna give the same answer, c plus 2. Therefore now, so to be continuous, I mention again, to be continuous at x is equal to 0, the limit x approaches 0 from the left hand side, f of x should be equal to limit x approaches 0 from the right hand side, f of x should be equal to f of 0. Since we have f of 0 and f of from right hand side f of x is same equation, we can get one of them, c plus 2, and equalize to the left hand side limit f of x. So it's going to be c square. So let's bring everything to the one side. It's going to be c square minus c minus 2 is equal to 0. Now I can factor this one. So when I have to find a number that when I add, I have to get -1. When I multiply, I have to get -2. -2 and +1 will work. So -2c plus c minus 2 is equal to 0. Then if I take c common, it's going to be c minus 2 plus 1 common, c minus 2 equal to 0, c plus 1, c minus 2 is equal to 0, c is equal to -1, comma, c is equal to 2. So these are the two values. So we can say that function is continuous on R when c is equal to -1 and c is equal to 2, or c is equal to 2. So this is my final answer, and this is how we approach this question. I hope you guys like this video. See you next time.